Planck's quantum theory. In 1900, a German physicist, Max Planck, had studied radiation emitted by a hot black body and proposed quantum theory of radiation. So the main postulates of the quantum theory are: atoms emit or absorb energy at intervals in the form of energy packets or wave packets called quanta or photon. This energy is in discontinuous or discrete manner. So what are photons? Photons are the energy packets which helps the electrons to jump from one energy level to another energy level. Now look at the diagram here. These arrows shows the photon. So what are the properties of the photon? Look at here, the photon is a piece of energy, as we have already learned that it helps the electron to jump from one energy level to another energy level. So photon is simply a piece of energy having no mass, no charge, moves at the speed of light. Energy of the photon is quantized. So what is meant by quantized? Quantized means distributed or not in between, just like a ladder. Photons are emitted or absorbed in whole number and never in fraction. The energy of the photon is directly proportional to the frequency of radiation emitted or absorbed. So, the energy is directly proportional to the frequency. So here we remove this proportionality sign and we use the constant here. So look at the equation here, that the energy of the photon, which is denoted by capital E, is equal to h, which we use instead of this proportionality sign. Here h is a Planck constant and its value is equal to 6.626 into 10 raised to power minus 34 joules second, where this mu denotes the frequency of radiation. So the energy of the photon is equal to h mu, where h is the Planck constant and mu is the frequency of the radiation. As we know that the frequency of the radiation is equal to c divided by lambda. So by putting the value of the frequency in equation A, we get E is equal to, or the energy of the photon is equal to h c divided by lambda. Now we know that the wave number is equal to 1 by lambda. So putting the value of the wave number in equation B, we get E is equal to h c mu bar. So the two forms of the energy of the photon by the Planck quantum theory are that E is equal to h mu and also E is equal to h c mu bar. Now look at the Planck quantum relation here. Here energy of the photon is equal to h mu, that is equal to hc divided by lambda. Now look at the equation where the term frequency and the wavelength is used. And we know that the wavelength and the frequency is for waves. So here the Planck relation tells us about the wave nature of the electromagnetic